This is question 3 from the SACE Stage 2 Physics Course Companion from Subtopic 2.2. A potential difference of 5 times 10 to the power of 3 volts is applied over two plates which are separated by 8.5 centimeters. An electron enters midway between the plates at a speed of 2.5 times 10 to the power of 7 meters per second. What we are trying to do first is calculate the magnitude of electric field between the plates. So this is fairly straightforward. All we need to do is use the expression E is delta V over D, and here delta V is 5 times 10 to the power of 3, and the separation is 8.5 centimeters. And substituting that into our calculator, we get 5.88 times 10 to the power of 4 volts per meter. That was fairly straightforward. Second, we need to calculate the magnitude of the acceleration of the electron as it enters the region of the electric field. Again, this is another straightforward calculation. So here, just using the expression A equals EQ on M, we've just calculated the magnitude of the electric field, so that's just 5.88 times 10 to the power of 4 multiplied by the charge of an electron, which is 1.6 times 10 to the power of minus 19 coulombs, all over the mass of an electron, which is 9.11 times 10 to the power of minus 31 kilograms, which if we substitute into our calculator again, we get 1.03 times 10 to the power of 16 meters per second squared. So those first two questions are fairly straightforward, easy calculations. Part C, why does the electron accelerate towards the upper plate? Well, there's two ways we can think about this. First, we understand that the electron is negatively charged and the upper plate is positively charged, so it's going to be attracted to that due to the charge. Or we can think about it in terms of the forces due to the electric field. So here, the electron experiences a force because of the electric field between the plates, and that force is directed vertically upwards towards the positive plate. So we can make two notes about this. So first, the electron is attracted towards the positive plate because the electron is negatively charged. Or if we think about the electric field and the forces, so the electron experiences a force directed towards the positive plate due to the electric field between the plates. Alrighty, so that's C. Part D, calculate the time taken for the electron to reach the upper plate. This is a straightforward Vervat's type question. So here we have V0 is 0 because we're only thinking about the component of the velocity in the direction of the acceleration. So here the initial velocity is all horizontal, so the initial vertical velocity is 0. V, don't care about at the moment. A is, we've calculated before, 1.03 times 10 to the power of 16 meters per second squared. T is what we're trying to work out, and S is halfway between the plates. So if it's 8.5 centimeters, then S here will be 4.25 centimeters. So we can just use one of our Vovat's equations. So here S is V0 t plus half AT squared. Since V0 is 0, we can just rewrite this as S is half AT squared. We want the time, so just rearranging this for time, it's fairly easy. So t will be 2s on a all square rooted, which if we substitute into our calculator after this, so 2 times 4.25 times 10 to the power of minus 2, all on our acceleration, 1.03 times 10 to the power of 16, all square rooted, is 2.87 times 10 to the power of minus 9 seconds. Finally, part D, we're calculating the horizontal distance travelled by the electron as it reaches the upper plate. So here, this is fairly straightforward again. It's just like all the projectile motion questions, that d equals vt. We've just calculated t, and the time, the velocity is 2.5 times 10 to the power of 7. So we can just substitute these in. And the time, 2.87 times 10 to the power of minus 9, which if we substitute into our calculator, we get 0.072 meters, or it's just a bit nicer if we write that as 7.2 centimeters. And that's it. So that's not too bad. It's pretty much just like projectile motion, but slightly different. But the actual calculations are, fairly easy.